Can you hear me?
Hello?
Yeah, I hear you. Okay, so I do a little bit performance before you start. So just a second. So we started yesterday with the three workshop with the Starkware. Uh, three, Today we have three more workshops. Uh, Now we got topology. The hackathon it's hosted by Matchbox DAO and Mask Network. The prizes is up to $50K dollars. There is three teams to build: Web3 social, Web3 gaming, and Web3 info and general tech. We have 14 workshops on the first 4 days. This is our sixth one. The prizes, as I said, is up to $50K, and the first place get $20K dollars, and we get bounties. About us, Matchbox is the part of on-chain gaming, and Mask is on the part of social network. And our major partner is Starkware, and we prefer to build on top of Starknet, but you don't must to. Take a look about our judges, and I know you take a look before. And this is our partners. And about topology missions is to combine state of the art zero knowledge proof system, research with the world class creative and engineering talent to develop strongly on-chain worlds with rich gameplay, strong interoperability, and composability. And Gigi, it's your time. You can talk and explain us more.
Okay, cool. Thanks for intro. I'm hearing echo. Okay. All good now. Can I share my screen?
Yeah, sure. You have option down screen. You can just click share your screen, and then you can share it.
Okay, let's go live. Okay, are you looking at my screen, canva.com?
Just a second. Yeah, we can see.
Okay, so you can see this, right? Topologist journey.
Yeah.
Perfect. Okay, I think I'll limit myself to 30 minutes, and we can do Q&A afterwards. Does that sound good?
Awesome, yeah.
Okay. Yeah, because I fall asleep if a talk lasts longer than 30 minutes. Okay, so let's do this. I'm Guilty Gyoza. I co-founded Topology, and thanks for inviting me to the talk and the hackathon. I'm going to talk about our journey. So first of all, the mission of our company is to build deep worlds on chain so that we can unlock human potential. Now that's a very long-term vision, but in terms of how we approach that in the short term, we want to explore the limitations and the affordances of existing infrastructure through game-like experiments. Now, like video games are amazing. They touch upon many domains. They touch upon the arts. They touch upon technology. They touch upon community, and so on. So through making games, we can really explore the boundary of what can be done in the here and now. The status quo of the company, co-founders, me and Kenho Kim, or KK, my partner. We have a lead developer, Greg, and we have about 12 collaborators, developers and artists. The company was founded in towards the end of 2021, and we raised our C round back then. Okay, so today I'll be talking about the experimentation that we did from September 2021 to last month, January 2023. So we started with this. We came across Cairo because of dopewars.gg, and we realized that, okay, now blockchain is a place for making games. Let's do games. So what we did here is we trained a Q-learning agent in PyTorch off-chain, and then we converted the trained model into Starknet Cairo contract. And we wrapped that contract with a tic-tac-toe game. So essentially, you have an agent playing tic-tac-toe on chain. So if you send a transaction to make a move on the board, the blockchain will run the agent, decides on an action, and return the new board to you. So you can effectively play with an AI. And after that, we started to do some more cliche deep learning stuff. So this is a two-layer deep neural network that was trained on the MNIST dataset, and then the model, the two-layer deep neural network with a ReLU layer in between, was transformed via a script into Starknet contracts, and all the contracts are bundled and deployed on Starknet testnet. So essentially, you can feed the contract with a picture, which is just 2D array of grayscale pixel values, and then you get a prediction back, whether it's a digit 0 or digit 9, or any digit in between. So that's MNIST. After AI, we thought, why don't do some physics? Because if you want to make games, then AI and physics are just two very common components in sufficiently interesting and complex video games. So we started doing physics. This is rigid body simulation. On the left, you can see 4 rigid bodies connected with springs. On the right, you have 2 rigid bodies revolving around each other according to the gravitational law, Newton's law. So what's being done here is the numerical simulation of these physical systems across time was carried out in a Starknet Cairo contracts. Or in short, we were running numerical simulations in smart contract. So we can basically compute how physical systems evolve over time. So since we did a 2-body problem, I think we posted a demo on Twitter, and there's like ZK Sync people asking us to do 3-body, 4-body problem. And so we did this. This is a constrained 4-body system with 3-body and a tiny 4th body. Essentially, we like 3-body problem. We like the novel. So we did this, and it was a lot of fun. We get to simulate a very simplistic 3-body problem simulation on the blockchain. But then we scale back a little bit. Well, because in modern game engines, it's necessary to handle collisions between rigid bodies. This is like one of the most basic things all physics engines do. So we did this. These are circular rigid bodies that bounced around within a box, perfectly elastic box, so there's no friction, and there's also gravity. And so these circles bounce around, and they can collide, and they can bounce off of each other elastically. And what you're seeing now here is just the visualization of the physics systems. So the simulation was all computed on chain. What's done on the visualization side is just visualizing the coordinates, the whereabouts of the rigid bodies. Then we made Fountain, so we handle collisions. We generalized it a little bit. We made it into these pure function view function in contracts, essentially working like a library. So if you call these functions, you can carry out circular rigid body simulation where we handle the collisions. Then we shifted gear a little bit. So we did a little bit of AI and we did a little bit of physics. We started to think about the visuals. So this was our attempt at deploying GLTF models on chain. So GLTF is one of the common standards for representing 3D models. So there's 3D axes models being made in Blender, and the models were exported in GLTF files and transformed into Cairo contracts and deployed on chain. So the result is you can call the contract and retrieve the raw data of the model, of the GLTF model back. And if you run a tiny script to reconstruct the GLTF model back, you can render the model anywhere. So this is the GLTF experiment. We also did some audio experiment. So MIDI standard is one of the most common standard for audio data. So this was where we transformed MIDI files into Cairo contracts, and we injected hooks into the contracts such that you can call the function and manipulate its tempo as well as its pitch. So you can basically speed up or slow down the music. You can also, move the pitch up or move the pitch down of the music. This was just some additional fun experiment we did about RTO simulation. So for those who did EE education, I did EE back in college. This is one of the basic things that we learned about circuit design. It was basically writing circuits in RTL, register transfer level languages, and simulate those circuits. So this experiment was where we implemented the RTO simulator, a very simplistic one in Cairo. So you can run this contract and simulate a behavior of a digital circuit, AND gates, OR gates, NOT gates, and binary signals traveling through the gates. And then we did some more physics. So we thought, okay, we did collision handling among rigid bodies. Let's make it into a tiny game. Let's no longer do demos. Let's do small games. So this is a game where you poke at the white ball, and you're supposed to hit the other balls. And the colorful balls will give you score if you hit them, and the gray ball will reset your score back to 0 if you hit it. So that's the goal. The goal is to find good direction and good momentum so you can maximize your score. And then we work with Matchbox on this particular experiment. We made it into a Soft-to-Mint project. Soft-to-Mint is this idea that you can solve a problem to mint a record on the leaderboard. And of course, if you want to mint a token, NFT, that's the easy part. I think the interesting part is solving a problem and have the blockchain verifies you have solved the problem. That's the solving part. So this Soft-to-Mint was basically playing this game and to climb the leaderboard. So these scores are different players submitting solutions to the game and scoring different values, and get placement on the leaderboard. And the leaderboard is on chain. Okay, we did another Soft-to-Mint. So Soft-to-Mint 2 was not about physics anymore. It's a game where you draw a path across these colorful objects. And you're supposed to go straight when you go across a circle. You're supposed to turn a corner when you pass a square. And they're like additional rules you have to follow. All the rules are basically provided in the contract in the form of comments. So we basically ask players to go through GitHub, read the comments, and sort of recover the rules of the game. We did this because we wanted to get some playtesters that are somewhat tech savvy, and the playtesters we got was for Isaac. So Isaac was this experimental game that we did around the theme of three-body problem. Okay, so this was the lobby of Isaac, second round of alpha. You can see that a civilization was destroyed, but you can replay how the civilization ended. Right? So you can see the planet crash into a sun. These are 3 different suns, and the black square here is the planet. So the gameplay was basically all the players are trying to work together to avoid their fate, the fate of having their planet crash into a sun. And the way they can avoid that fate is to play this game. This game about building production pipelines to harvest resource and build equipments, and ultimately you build rockets. Rockets allows you to push your planet into different directions. Like Planet Generator, if you have read the 3-Body Problem original story. So this was the game, and we later move on to another experiment called Movie, later renamed as Mumu. The Movie is this visual programming game. Right? So you're programming these little things, circles that can move around. You can place them, and the circle can move around and grab stuff. This one is the earliest demo, so it was a little bit abstract. But if we move a little bit, so you can see there are 4 circles being simulated concurrently, and these circles execute instruction. Right, so WSD are the movement keys. Z and X are pick up and put down respectively. So essentially, you are like operating these little robots and moving them around on the board. And if we just jump to the season 2, so this was season 2, where you can see that players are programming all these different robots with instructions, and they're moving, and they're basically accomplishing mission together. And Mumu season 2 is still live. We are going to release Mumu season 3 pretty soon with a lot of incoming changes. So that is exciting. And this is another experimental game that we're working on at the moment. We are currently dogfooding and playtesting internally. So we can't say much about it yet. But as you can see, this is the early demo we did last June, I believe.
Token transfer.
So this is a fighting game. So you have a pixelated female character swinging a katana and dashing forward and dashing back. And what's interesting about this game is that you have AIs controlling the characters. Okay, I think someone has unmuted, but I'll just continue. So you have 2 AIs piloting the characters, and you can see hitboxes, right? So if you play video games, you know hitboxes are how video games backends handle collisions, detect and handle collisions. So these are hitboxes of their body and of their offensive action, respectively. So these are early screenshots. We can't share much because we're still playtesting internally, but expect that we will be announcing playtesting opportunity soon, where you can design AI to pilot characters to battle other characters fully on chain. So to sum up, we believe that verifiable computing will turbocharge knowledge production in human societies. A quote from Lattice is that this is essentially the computing renaissance. We are rediscovering what computation is useful for, and we're using that to transform societies. And so join us and think different, and we what we do is we fuck around seriously. If interested, feel free to reach out. Thank you. So this is my talk, and now it's Q&A.
Are you allowed to ask questions?
Yeah, go ahead.
Sure.
So I wonder, so for the last game, it's better to move the whole system on chain, the action game.
Yeah, sure. What was the question?
Oh, I'm just curious. Why do you think we should move this kind of game on chain? Like, what's the value added for the blockchain in this game?
Well, so since we started doing soft to mint, if you go back here, so if you go back here, okay, so here, right, you see Kobe, who's a crypto researcher at Geometry. He submitted this solution, which is characterized as this string. So this is like a hash value. But then his solution scored 80 points. Okay, so the point here is, if you think abstractly, what Kobe achieved here is Kobe recreated a knowledge, and this knowledge has some value. Value 80, that is the value of that knowledge in the context of this particular puzzle, right? So we think that blockchain is wonderful for recording inventorship, basically who invented what. And the inventions are quantitatively measured and verified on a blockchain. And because blockchain is this credible, neutral platform that can do important things without cheating, right? That's why we use blockchain, because it help us coordinate very important activities, such as deciding the flow of money. That's what we currently use blockchain for. That is the killer app. But it's not all what blockchain can do. That's just currently what we mostly use blockchain for handling money and money problems. And if we generalize from that, blockchain handles very important records, including knowledge and knowledge production. So coming back to the AI game, we think that every AI is a very important knowledge, right? Like, I designed an AI that is able to pilot this female character, and that is able to, defeat all the other characters, because my AI is able to make very clever decisions in terms of offense and defense, and deceiving the opponent and so on and so forth. If you play fighting games, it's mostly about deception and stamina management, right, and mana management, rage management, and so on and so forth. And that behavior, that AI, is highly valuable as knowledge, and so we think that that knowledge should be recorded on chain, and blockchain is where we verify that knowledge and we reward, we recognize, we celebrate the inventor and the creator of that knowledge. I hope that makes sense.
That makes total sense. Thanks for the intro, but I have a follow up.
Yep.
So if we care about this authenticity, this record of ownership, creation, there are various ways in Web2 where a trustless commitment is possible. For example, I think like most prominently those open source projects on GitHub. I think it's also possible. For example, we can commit some of the records to the chain, but not move the whole game engine on chain, because I think there's like a large overhead with the whole game engine on chain, and efficiency wise or like developer adoption wise. I think so. If we only care about trustless records, there are all kinds of different ways we can do this without blockchain. The whole
I completely agree.
game
Yes.
engine moving on chain.
Yes, I completely agree. I think so. One of the ways we understand this entire movement is that we think ZK is much bigger than blockchain. We don't have to discuss ZK strictly in the context of blockchain. Well, I think ZK becomes sort of surface to public consciousness because it's used for ZK rollup and layer 2, and it's a wonderful investment opportunity. Hence, everyone is noticing the potential of ZK. But we think ZK is much bigger. So you can run ZK VM off chain, and you can interact with the blockchain in various different ways, instead of running everything on a blockchain. So I think but I think we all agree that important things, is better handled trustlessly. I think that's the entire sort of Web3 movement, or the blockchain movement is about. It's about handling very important activities that matter in human societies without involving institutions and brands and big corporations and human trust. So I definitely think that the topology of computation will look very different. It will not be naively running everything on the blockchain, and we should not do that too. I don't think that's the optimal solution. But yeah, these are experiments. We are trying to explore the boundary, as we said earlier. And once we know the boundary, we can transcend the boundary.
Awesome. So in the future, you might explore, for example, like trustless off-chain compute and on-chain commitment using ZK. In that direction.
Yeah. So I think well we have some of us on-chain game developers have consensus around what should be done here. There's this notion of client-side proving. Like Dogforce did this too. Proving happened in the browser, and browser is off-chain. They have like Solidity verifying a proof from Circom. We can also do that in the Cairo space, or if you favor other flavors of ZK VMs, you can also do that. Yeah, so client-side proving allows us to only send proof, not the entire thing, to the blockchain.
I see. Yeah, that's awesome. Yeah, thanks so much for sharing all those.
Great.
Hi, Gigi. I guess I'll jump in here to ask a very quick question.
Okay.
So you mentioned, throughout all those experiments, we're basically trying to figure out what is the boundary of, basically existing, stuff we can do on the blockchain. What does it look like? So I'm wondering, throughout the above several experiments you have run through, I'm wondering what kind of limitations, or what does the boundary look like? What kind of limitations have you run into, when doing these things on the chain? So whether that's some limitation of infrastructure or developer tooling, just want to know what kind of obstacles are in your way to prevent you from, doing more, say, grand or, basically more amazing experiments.
I think, yeah, so I think we gave a talk last September in Ho Chi Minh City, precisely about the bottlenecks that we recognize in the blockchain ecosystem. But I want to say very quickly that limitations aren't always bad. Like Super Mario was invented because of the limitation. They had all these wonderful bit packing ideas because memory was so scarce. But that ended up being a legend, right? A legendary design that just lived on decades after decades. So I would say if you come from a design background, you will know that with any medium, there are constraints and limitations. But precisely because of those constraints and limitations, it helps you design the thing. It constrains and therefore contextualize your design. It helps you to design better. But yeah, coming back from the designs domain, I think that the blockchain space, in one word, early. But I think that doesn't say much. Some people may say, well, blockchain has been here since 2009. It's not doing much. So we should probably be more critical of it. But I think blockchain is so early; it is like ludicrously early. If you look at how blockchain programmers discuss developing stuff on the blockchain, they talk about contracts deploying at which address. They talk about VM, talk about languages running on the VM. These, I think, is equivalent to like imagine you use your you program on your Mac computer or maybe your Windows computer, and you have to precisely remember which memory address, like DRAM address or like your solid state drive address, where your particular program is deployed. You have to remember the linker, the proxy pattern where all these addresses are, and you have to have a scratch pad writing down all those addresses, like in hexadecimal form, right? This is super low level stuff that the computer society has transcended many years ago. Like we had memory hierarchy, we have file systems, we have all these different things. So nowadays we would never mention memory address even in programming in C, right? We are dissuaded from manipulating raw pointers. That's just dangerous. But now in blockchain, we're all manipulating raw pointers, like hex addresses, right? So there's a lack of abstraction that limits the productivity of blockchain programmers. And I think there's something called ETHFS, right? Like ETH file system, being experimented upon, and that is a wonderful thing. I think they released launching NFT, working with the ETHFS, I think just maybe a day or two ago. So that was wonderful, and that actually signifies that we are going to build more abstraction on the blockchain. So in the future, we don't mention Uniswap contract deploy at 0x blah blah blah. We have more expressive ways of describing objects that lives on the blockchain. So that's one thing, and I think other things include, ZK is so early. There's lack of standards in terms of how proofs get generated and gets verified. In a sense, whenever you look at a ZK connection, there's proven there is verifier. So the way I see it is it's like a glue, or it's like a glue is a core term. So it's like a glue. So like I can glue two systems together by having one system speak proof and the other system verifies the proof. Therefore, I can glue the two systems together trustlessly. And I think if ZK is to become a wonderful glue, we need to have standards around how ZK glues work. So there are teams working on this, right? Multiple teams working on like ZK IBC. How do you connect blockchains together? How do you connect rollups together? How do you trustlessly bridge across state machines? I think that's one area that needs to be worked upon. Yeah, and I'll mention these two. I think there are many more. But basically, I think on a blockchain, there's just lack of abstraction. And lacking abstraction makes all of us very developers that are working on raw CPU. That's just not very productive. And that's prone to, security issues and so on.
Mm-hmm. Yeah, thanks for mentioning the above too. And I certainly believe that, given better tooling, not just purely higher TPS, we can probably achieve more within blockchain. Yeah, thank you, Gigi.
Great.
I guess I have a follow-up question. So we've just witnessed your journey from like a year ago all the way to right now. But I still feel like those are a little bit, I guess, disjointed. I'm wondering like how are you going to like tie those all things together and so all of those looks like, okay, there's one mini game here, one mini game there. How are you going to tie them together moving forward?
Yeah, that is our goal. That is our goal this year. So this year we're less about experimentation. We're heads down building. You will hear from us later this year.
Sure. Yes, I'll be very looking forward to. And also, well, I guess to follow, even follow up a little bit on that, what's your thinking on the other folks working on launching games, including Lutron, Lord, including Lattice folks, and including what's the other one's called, Curio, right?
Yeah.
What's like the difference between you and maybe the others?
Right. I think that and there are many more teams, right? There's like Influence, and there are teams that work on parts and systems that support on-chain games like cartridge and so on. There are many more teams. And there are teams outside of Starknet ecosystem. Yeah, but I think we're doing very different things. And that is obvious because at the end of the day, it's the entrepreneurs, it's developers that are driving these, and they have different philosophy, aesthetics, and they have different strength in their technical skills. And I think most importantly, we have different hypotheses. And so the things we do are essentially testing our hypotheses. And I think time will tell which, or I think multiple of us will discover interesting ways of leveraging blockchain to make interactive multimedia projects. Yeah, like video games. There's so many different genres that became successful, and they touch upon broad landscape of audience, different player categories. So this is definitely not a zero-sum game. This is I think on-chain game is not established yet. If you ask any regular video gamers in the world, like actually in the world, not in this tiny little bubble that's strangely obsessed with blockchain, I think most of them will say blockchain and video games, I don't see them directly connected, other than maybe gambling and NFT stuff, which most players hate. You also see Minecraft creators starting a studio that tries to make NFT powered game, but without mentioning NFT to the players. And I came across their Twitter space advertising for like grabbing new island and explaining their gameplay, and they didn't mention any NFT, but I think in their like fundraising PR, I think they mentioned they are leveraging blockchain. That's why they got the fund. But yeah, I think for most gamers, they don't care. And so all of us on-chain game pioneers are essentially working together in a sense to try to establish this scene. Yeah, that's what I think.
Sure. Thank you for the very comprehensive answer.
Anyone else? Okay, so Gigi, thank you for the workshop. It was awesome. Really appreciate it, and I'm sure that more people have more question in the chat. So maybe you can check it one day on the hackathon and answer to other people. And again,
I was about to say that we also have a Chinese group that Gigi is also part of, so maybe there are going to be questions popping up there.
Okay, awesome.
Perfect, thank you, and good luck with the hackathon.
Thank you.
Good luck.